This conference will now be
So guys,
recorded.
let's see what we have for the day. So we're gonna learn something known as perceptrons for the day, and we will be able to implement some logical gate operations with respect to your perceptrons, and we'll even see how we can write a small, artificial neuron a network at the same time. So once again, guys, deep learning is all about ANNs or artificial neural networks. So how a neuron will work? For a neuron to work, you have a dendrite which receives the signals from the other neurons. We have a cell body where you sum up all the inputs, and you got an axon where the signals will be transmitted to the other nerve cells or the neurons. So our computer science approach towards a neuron is a perceptron. So for perceptron to work, right, it is going to be a transfer function or a summation function followed by an activation function. So you give the inputs to the transfer function along with the weights. Of course, we can have one more additional input called bias along with the weight. So we will be summing up all the data in this summation function, and your activation function is going to decide based on the threshold whether the result should be given or not, right? So in the perceptron, you add all the inputs, weighted inputs in the summation function, and then you give one result as sum to your activation function, and activation function will produce the final output, right? And this output can be further used to classify, or we can use it as a regression value. In our upcoming discussion, we'll see that how it can be managed, right? So guys, this is one more example. This is all what we have seen earlier, right? So I'm just making you guys to review the same. So perceptron will have this weighted inputs which you're gonna add, and finally you're gonna come up and sort of sum them up and check the summation with respect to a threshold value, let's say theta. Now, for a binary classification problem, we may give the result as 1 in case the sum is greater than 0 or maybe equal to 0, depends upon our use case, and we can give 0 otherwise, right? So let's see the next part here. Anytime you can have a bias. When you add a bias to your summation function, you're trying to deviate your line of regression towards left or right, or line of classifier towards left or right, right? So bias is all about where you are going to come up and certainly do an additional action to make your result fall into some category. So guys, this is what we already discussed in our previous presentation of deep learning. So today what we're gonna do is we're gonna understand how we can implement a neuron to form your logical gate operations. All right. So we want to write a neuron. We want to write a perceptron model to implement our logical operations. So we got not and or, right? So we got these logical operations. We're gonna have a neuron. We're gonna have a nerve cell perceptron, maybe multiple perceptrons. Maybe we need to write a network of perceptrons, right? So we have to adjust the weights. We have to adjust the threshold. We have to choose an activation function so that we can form a decision boundary. Let me show you what is meant by the decision boundary when we are talking about these logical gate operations. But I think these gate operations are very simple to everyone and clear to everyone. For or, you get outputs when you have either any one of the input as true. For and, you need both the inputs to be true, and not is going to negate, convert 0 to 1, 1 to 0, true to false, false to true. So let us see what is meant by decision boundary. Consider your logical and your input 1 and input 2, right? So this represents a point on your, let's say, graph, right? So I got this first point as 0 0, which is the value 0. So the first class black represents 0 for us here. Then I got 0 1. So you got this 0 1 represented here. then we got 1 0 represented here, and then we got 1 1 represented here. So I can draw a line here. This may be the line of classification, where we are saying that points below this line, they represent the class black, and the points above represents the class white, or zeros and ones. Same way, this can be thought for your OR. In the OR operation, it's gonna be 3 1s and 1 0, right? So you can have a decision boundary here. So guys, can I get a smiley? What is meant by decision boundary? Is that part clear to everyone? Anyone facing any challenge here with respect to the decision boundary part? So Shashi, this is just a logical decision boundary as of now, right? So what we are trying to understand is that your logical AND will work in this manner, or will work in this manner. So it is just the logical part for us to understand. We are not going to derive these decision boundaries somehow, but how AND works is very simple. All the inputs should be true, will give you true, right? For the classification problem, right, your both the features should be true, so that I can label this class as 1. So any one feature should be true, so that I can label it as class 0. That's how we consider this guy called logical AND. Good to go, Shashi? So this decision boundary is just the logical part here, right? So we are not creating any decision boundary through this program. So what I will be doing is I will be simulating these logical and or not operations with the perceptron approach, right? So let us see how we can deal with it. Let me quickly open the pie chart. All right, guys. So let us now come here and write this program. New Python file, session 53. So we are going to create something known as your activation function, right? So I'm going to define an activation function for the perceptron, and for the perceptron you have to have a submission function. So let's write in an object oriented way only. I'll write a class called perceptron. So we've already seen this, guys, right? So perceptron, the moment you create perceptron, right, this guy will have some inits for us, in a way of that it will take some inputs, right? So we're gonna have some inputs which we can use. So as of now, I'll just write the paths here, and I will have this function called submission function. So submission function is going to take inputs and the weights, right? So I'll take X and W as inputs and the weights. Then I'm gonna write this function called activation. So in the activation function, you're gonna take sum as input, right? And I'll write the pass here. So this is kind of your, you can see, perceptron model, right? And let us now come here and define the main function. So guys, I'm going to have my first input, right? I'm going to create array of inputs. Let us create array of inputs. In order to do that, I'm going to use my NumPy. So import your NumPy as NP. So I'll tell you the reasons why I'm going to work in that way. So I'll have an input 1. So in the input 1, I'm going to say NumPy dot array, and this array is going to be 0 and 0. This is my first input. Then there is a second input, third input, and the fourth input. So 0 0 0 1, and thereafter 1 and the 0, and 1 and 1. So if you will start thinking of this fellow, so why I'm giving these 4 inputs here and how it's gonna work for us. So there is this perceptron which is divided into 2 parts, as we know, right? So perceptron is divided into 2 parts. The first one for us is going to be your summation function, and the second one is going to be activation function. So thereafter you are going to generate a result. So result will be generated in this manner. And what I'm going to do is I'm going to give this perceptron 2 inputs. So I have a total of 4 inputs, but 1 input over here means 2 features, right? So how these inputs are going to be for us? So we are saying 0. So I'll just come up and mark this input as x1, this input as x2, right? So x1 over here is going to be 0, 0, 1, and 1, whereas x2 for us is going to be 0 1 0 1. So this is how the data is going to be associated. So for the first time, your summation function is going to take 0 and 0. For the second iteration, it's gonna take the value called 0 and 1. Then your next iteration, it's 1 and the 0. And then the last iteration is 1 and the 1. So I have made 4 different set of inputs, right? So there are only 2 features, x1 and x2. This is how we are trying to work on this part here. Can I get a smiley from all of you? Is this perceptron model clear to everyone? So what we are trying to do here, we want this perceptron to work like 3 things, right? And, or, and not. So this is your perceptron. So we want this perceptron to work like either and, or not, right? To begin with. So let us come here and proceed further now. So I got this 4 set of inputs, right? So my perceptron should work on this 4 set of inputs, and I got this input as x1 and this input as x2. So that is how the things are going to work for me. So in the main now, so I'm gonna say perceptron is an object of perceptron, right? So I can just come here and say print perceptron created. Now since you have these lot of different inputs, if you can see I have these 4 set of inputs. So what I'm gonna do is I'm gonna write another function, define let's say set inputs, and I'll take the inputs here, and I'll say self dot inputs is inputs, right? So I will be creating these inputs as an attribute. So for my perceptron, I'll say set the inputs to be your input 1. So create Perceptron, right? And here you say set inputs. So Shivani, this is what you got as your Perceptron model. So we got this logical inputs, right? So 0 0 as one input, 0 1 as another input, 1 0 1 1. So these are the four set of inputs which we want to pass to our Perceptron. So in case this Perceptron behaves as logical AND, so it should only give us the output for 1 and 1, not for any other case. Can I get an acknowledgement, Shivani? This is what we are trying to do here. We want this Perceptron to behave like logical AND, logical OR, and the NOT operation, right? Okay. So let's come here now. So I have settled the input here as input 1. So I got the input available here. So we don't have the weights as of now, right? So weights I have to somehow consider myself. So in my summation function, what I'm gonna do is I'm not gonna consider this x and w, right? So input says x only, which I have. So let us assume the weights. So I'll say that there is something known as weights, which I'm going to create a numpy array. Or what you can do is you can create this weights below here. It's a numpy array, and I'm going to consider the weights as 0.5 and 0.5. So just assuming some weights, right, to the inputs, because every input is going to have a weight. So if you see this Perceptron model, right, so every input x1, x2, xn, you got w1, w2 to wn, right? So you have the weights associated. So I'm considering this weight value as 0.5 and 0.5. So this is just an assumption, right? Assuming weights. So when you have to come up and say summation, or I can assume these weights exactly during the construction of my perceptron, right? I can just say that I have these weights, I have assumed these weights while creating the perceptron. So this is how you create the perceptron, and this is how you assume the weights to be in the perceptron. So you settle the inputs into your perceptron, you say set the inputs, and now what submission function should do? So for my submission function to work, it should calculate the sum. So sum is supposed to be calculated by saying np dot product. And guys, what I'm doing is a dot product on your self dot inputs and self dot weights. So let us print the sum here. So let's come here and say perceptron dot summation. So when you will say perceptron dot summation and you will run the program here, so this gave you the value as 0.0. So let's see how it's gonna work as 0.0. So for your input one, both the guys are 0, right? So 0 into 0.5 is 0, 0 into 0.5 is 0. When you add, you get the value as 0. Can I get a smiley from all of you? So in my activation function, so I'm gonna say your activation function is going to work with your sum value. So whatever the sum you are going to generate, right? So let this be a self dot sum, right? Let this be the part of your object, right? So summation is comma sum. So in the activation function, you need not to take any input now. So I need to decide a theta, a threshold value. So what I'll do is I'll say self dot theta is equal to 1. So assuming threshold. So I'm assuming this threshold to be 1, right? Weights to be 0.5 and 0.5. Perceptron created with weights and the theta value. So now in my activation function, in case the sum is greater than and equal to theta, so I'll say return 1, else you return the 0. So this is going to be self dot theta. So you wrote an activation function. This is going to be a binary step activation function. And when I'm saying summation function, this is basically your inputs multiplied by the weights, right? So sum of, that's like your dot product more or less. So for my input, I got this summation done, and now I will say print me perceptron dot activation. So what is the result of activation function for the input one, right? So I'll just write here for input one, result is comma perceptron dot format. So you got this 0 and 0. So I'll just use this string only. So you run the program. All right. So what did this happen now? So just give me a moment. Okay, so my bad. Yes. So here we go. So for 0 and 0, the result is coming to me as 0, right? So let us try with the another set of things. So I'm gonna set the input 2, then the input 3, and then the input 4, right? I got this 0 and 1, then 1 and 0, and finally I got the data as 1 and 1. So let's run the program and see what you get as in outputs. All right, so what exactly happened for us? Just give me moments. Submission is my bad. This is supposed to be self dot sum. All right. So now let's run the program. So Perceptron created submission is 0.0. So for 0, result is 0, and summation is 0.5, right? For 0, 1, the result is 0. For 1, 0, the result is 0. For 1, 1, the result is coming out as 1, right? So it means with the kind of weight I have associated, that's like the weight for me over here as of now is 0.5 and 0.5 for both of them. So both of the inputs, we have a constant weight of 0.5. Same weight 0.5 for both of the inputs and for any input, right? So typically what we are doing is we are doing for this first fellow, for this first guy which you send as to the submission function, you are doing 0 multiplied by 0.5 plus 0 multiplied by 0.5. For the second fellow, you are doing 0 multiplied by 0.5 plus 1 multiplied by 0.5. For third, you are doing 1 into 0.5 plus 0 into 0.5, and lastly it's 1 into 0.5 plus 1 into 0.5. So this is what you are doing in the summation functions, and whatever the results which are being generated here, so that you are giving to the activation function, and activation function will check against theta. So theta for us is assumed to be 1. It should be greater than or equal to 1. So here your activation function, the value for theta we are considering greater than equal to 1. So what we will see is that this guy over here is going to yield some results for us. So what are the results which we are getting here? So this is 0. So this you will get as 0. The second one you will get as 0.5, then 0.5, and the last one as 1. I hope this makes a sense to everyone, right? These are the 4 results for which you are going to work. And of course, only for the last result, which is this guy 1, so you get this output coming here as 0, 0, 0, and 1. So this perceptron with the weight as 0.5 is going to work as my logical AND operator. So perceptron as logical AND. Guys, can I get a smiley from all of you? Perceptron as logical AND. An acknowledgement awaited from all of you. I hope everyone is good to go here. So looking at this image, what do you think, guys? What I should write so that I should get the outputs as 1, 1, 1, and 0. I want to convert this guy to logical OR, right? So how I should be able to deal with it? So what should be the value of the weight which I should consider so that I get the output as OR operation? You have to do a hit and trial here, right? You can take your notebooks and pens and you can try to see if you can solve it. So guys, acknowledgements awaited from all of you. So can you please try in case this weights which you assumed to go as 1.1 for logical OR and test if it is going to work for us. If you make these values of weights as 1.1, right? Instead of 0.0, if you make the values of weight to go as 1.1, what will be the output for the perceptron? So guys, make this weights to go as 1.1 and then see what are the results you're getting with the same activation function. Are we getting it as logical or not? So please acknowledge, guys, in case you're good to go here. So the moment you keep this value as 1.1 with the weights, so what you see is for 0, 0 result is 0, for 0, 1 result is 1, for 1, 0 it is 1, and for 1, 1 it is also as 1, right? So the same perceptron is going to be converted into your logical OR model. So it means what? That you can manipulate the weights. The moment you manipulate the weights, right, you get to see a different operation on your same inputs. A smiley waited from all of you guys, an acknowledgement waited from all of you. I hope this is clear, right? So how we modified the weights and how we got our results. So we have a query here. So why we have not taken the values of weight as 1? So guys, the value of weight can be chosen by hit and trial, right? So you need to see which value of weights fit in to get your results. Now let us take the value as 1. So when you will take the values as 1, so you even get the same results, right? You take the value as 0. Let's say 1.5 here and 1 here, right? You'll get the same results. So you just need to come up and see that what and all weights we can keep here. So I'll just put this over here. So we are saying this term called assuming weights. So weights may be assumed by hit and trial method to get our expected outputs, right? So we're gonna come up and do some hit and trial by which we can get our expected output. So let us now see the other part. So I'm just gonna take this entire program. So I want to implement this NOT operation, right? So logical NOT. So for logical NOT, I don't have these arrays of inputs, right? So what I got is I got input as either 0 or 1, right? For input 0, the value should be 1, and for input 1, the value should be 0. So what I'll do is I'll come here and we need to consider the weight as well, right? So I'm gonna assume a weight. So this is going to be just a weight for me, and I'm going to assume this weight as in, let's say, the value as -1 and the theta as -0.5. Now guys, we can even change this theta. So when I'm having this guy perceptron for logical and or, it's not just the weight, right? So you can change the weight, you can even change the theta or threshold value to bring your outputs. So weights may be assumed by hit and trial method to get our expected outputs. We can also manipulate threshold theta to get our expected outputs. And one more third point, we can even add an external input called bias to manipulate results as per our expectation. So you can anytime add one third input with the help of which you can get the data, right? Which you can get the output. So let's come back to perceptron model implementation for your not operator. So I'm assuming the weight is -1 and the threshold value is assumed to be 0.5. So the input is going to be a one single input for us, right? It's not multiple inputs. So in the summation function, I'm not gonna work on numpy, right? It's gonna be more simpler for me. Why? Because the summation for us is just your self dot input multiplied by self dot weight. So what we have is we have this guy in a different way, right? So you have only one single input for the not. You don't have multiple inputs. So perceptron's gonna take either input as 0 or 1. So there is only one single input multiplied with the weight. So you can't come up and add another input because not is to change 0 to 1 and 1 to 0. So in my activation function, right, we're gonna work in the same way. It's a binary step activation function. The moment the data goes greater than or equal to theta, you return 1 or you return 0. So let's create a perceptron, set the input as input, and thereafter let's see what is the result when you pass this input as 0. So when you pass the input value as 0, right, you do a summation. So for 0, result is, let's see, perceptron dot activation. So run the program here. So for 0, result is going to be 1, and let us change this guy to 1. So I'll just pass this input over here as 0. Input is 0. Let the input be 1. So for 1, the result is going to be 0 for me. So this is the implementation of perceptron as logical not. So this is the very first step for your deep learning, that you should know what is a neuron and how it's gonna work for us, right? So anyone with any challenge here, guys, let me share this program over the chat, right? This logical not. Please review the program and let me know in case you have any challenge here while implementing this logical not. Are we good to go, guys? Can I get an acknowledgement from all of you if we are clear till here? All right. So let us see if we can implement the same program with the bias. So you got this perceptron. So let us assume the weights as 1 and 1, right? I got the weights as 1 and 1 for, we don't care about and or operation. We got the weights as 1 and 1, right? And theta value. The next is assumption in the theta value. So I'm considering the value of theta as 0. So you create the perceptron, right, with your array, with your weights array, with your theta value. You set the inputs in the same way. You have a summation function, you have an activation function. So what is meant by bias, right? So bias means that there may be one additional input which you are going to add to your perceptron model. So this additional input is sometimes required to be given. We call it as a bias to change your decisions, right? You got this bias. So this is going to be again one value, right? So there may be some input x multiplied by some weight. This is what the bias is going to do for us. So I'll consider the value of bias as one single value. So I will not say some x into w part here. So what I'm saying is, while putting up this summation function in my perceptron, I'm going to say a bias value, right? So let us consider that there is a bias value which is going to be minus 1.5. So this summation function takes a bias value as input. So external bias as input. So once you do this dot product, you thereafter add this bias into your sum, right? You add the bias into your sum of your dot products. So this bias I am putting as minus 1.5. Let us see what happens with the bias value as 1.5. Okay. So let's come here and say this bias is minus 1.5. Assumption, right? Once again. So we pass this bias over here as input in the submissions. So in case I have this theta value as 0 and numpy array as 1 weights, and assuming that you don't give any bias, right? So there is no bias. So when I say bias as 0, there will be no impact on your weights, right? So you run the program. So what you see is for every data which you can see, your result comes out to be 1. So this is not at all a logical and logical OR operation. So when I'm choosing the value of theta over here as 0, right? So it means it has to give every output as 1 for me. And the weights are also 1. We have chosen it 1. So the moment I add this external bias as the value, a negative value called minus of 1.5. So you run the program here. So what happened? Bias value minus 1.5 is going to work for me as logical AND. So what happened typically? So you said 0 and 0 as your first input set, multiplied by 1 generates 0, and bias value minus 1.5 will make it to minus 1.5 and it will generate 0 for us, right? Then 0 and 1. So 0 multiplied by 1 will give you 0, 1 multiplied by 1 will give you 1. Correct? So you get the summation as 1. So you subtract minus 1.5, you get the negative value, again the value is 0. So for only 1 and 1, you have the summation as 2, and you subtract the bias as 1.5, which results into 0.5 greater than 0, giving you the value as 1. So it's not just your weights or the theta, you can even have an external bias to make your perceptron a successful model. Can I get a smiley as an acknowledgement from all? Are we clear till here, guys? So I'm just going to share this code over the chat. I want you guys to give me the value of bias so that I can make it a logical OR. What should be the value of bias so that the same program should work as logical OR? So take a moment and try to acknowledge me with the values. So anyone with success? Can I get an acknowledgement, guys? Anyone who is... So this is the same model, right? And in the same model, what we are doing is we are putting up this value of bias so that we can manipulate the results. So Karthik says, let us put the bias value as 1. I'm going to put the bias value as 1, guys. So the moment I put the bias value as 1, it gave me the result as all ones. So it's not working for us. So anyone else, guys, who would like to come up and do some hit and trial, or you have just tried some mathematical part and seen what it can be? So Sahil says, let us put the value as -1. Yes, let's try with the value as -1. So guys, what you see is for -1, this guy is going to give me the correct results, right? So logical OR can work with -1, can work with minus of 0.8. So it's like changing and manipulating the data. It can work with minus of 0.5. So you need to always, kind of see how the things can work for us. But I hope you understood what is a perceptron and how we can write logical and or operation with some different opinions. The first view of writing a perceptron may be selecting the appropriate weights and assuming an appropriate theta. Then the next part may be you have some assumptions on weight and theta. They are not working for you somehow. So you add your bias as a factor, right? So you add another factor called bias. With the bias, you achieve your results. Can I get the acknowledgements from all? So how perceptrons will work in the deep learning models? All right, guys, great. Thank you so very much. So I'm just gonna give you this small assignment here. So the part of assignment, you implement logical knot with your bias. All right, so this is what you need to implement. So coming back to my presentation here, so we understand what's a perceptron, what are logical gate operations, as in logical and logical or and logical not. But there are few more, you see, the part of operations. So we got something like XOR, right? Exclusive OR. This guy says 0 0 should give me 0, 0 1 should give me 1, 1 0 should give me 1, and 1 should give me 0. Now we got a challenge here. The challenge is that when you plot the outputs with these data points, so you may have two decision boundaries, right? If you see, guys. So you got this 0 0 and this guy has 1 1 yielding the same class, whereas these two guys are yielding the other class. So you can make decision boundaries in some couple of ways, right? So what different ways we can make the decision boundaries, guys? So let me show you. So we can come here and either do this part as well. If you don't want to make the decision boundaries in this way, you can have the decision boundaries in this way as well, right? So the entire point of discussion here is that writing a perceptron for XOR operation, right? How it's gonna work for us. So it's not gonna be that simple. So this is the step where in order to write a solution for your exclusive OR operation, you need to involve a lot of perceptrons now. So for example, I will have two different perceptrons to reach out to an output, right? So we'll see this implementation of XOR or building up of our very first neural network. So today what you have done is you have implemented neurons, right? You understood that how I can write a neuron or a perceptron to yield a result. So tomorrow you're gonna see some multiple perceptrons working all together, right, to implement this XOR operation. So I'll push this program over the GitHub now. Perceptron implementation as logical or and not. Anyone with any query, guys? Please feel free to ask in case you have any query or any concern. So session number 52 is uploaded on the GitHub. You can just cross check the same Sahil. So guys, can I get an acknowledgement? Are we good to go? Shall we move towards closing the session then? So Arshdeep, Divya Hitali, Jasnoor Karthik, Maninder Manmeet, Navjot Neha, Palvi, Pradeep Puranjit, Rhythm, Roop Kaval, Saib Noor, Sahil, Saloni, Sarthak, Shalu, Shashi, Shifali, Shimpa, Shivani, Soumya, and Vaibhav. Guys, all good to go? Anyone with any query can please raise in case you have. Right, guys, thank you so very much. So we'll be closing the session now, and we'll meet once again tomorrow, where we'll be discussing how we can further move ahead with your perceptron models, and we'll write a small XOR model structure. And then I'll take you guys to PyTorch and TensorFlow introductions. Thank you guys. Bye bye.